In this tutorial, we have to extract lots of properties from steam at various conditions. So let's look at the first exercise. We are asked to find the specific volume of dry steam at 0.5 bar absolute. Okay, so let's go to the saturated steam, water and steam tables. In this case, we are at page 3, and I have highlighted 0.5 bar, and we are required to find dry steam. So dry steam will be the condition Vg, and we get a value of 3.239 cubic meters per kilogram. So let's write it up. So that completes part A. Now let's look at part B. At part B, we need to calculate the internal energy now of 3 kilograms of dry steam at 175 bar absolute. Now let's find where we are on our saturated water and steam tables. If we go to our page 5, you will see we are at the tail end of our saturated water and steam tables. 175 bar, and you notice we will need to find the internal energy, and we use UG because that is saturated steam, which we usually call dry steam. So let's get back to our sum and complete it. So in section 2, as you can see, we got the internal energy, but now we have to consider the internal energy for 3 grams. We have a capital UG, and our final answer is 7,173 kilojoules. Next, let's see part C. Enthalpy, again 3 kilograms of steam, but this time 30 bar absolute, 400 degrees centigrade. So we have to find where we are on 30 bar and 400 degrees centigrade. So let's use the steam tables. Okay, we find that at 30 bar, superheated conditions exist. Okay, how do I know it's superheated condition? Look at the saturation temperature. It says 233.8. Our steam is at 400 degrees, so clearly it must be superheated. We scan the temperatures 400 and home in on the cell where we can extract our data. In this case, we are required to calculate the enthalpy, which is 3,231 kilojoules per kilogram. Let's get back again to complete part C. Right. Let's look at the answer for part C. We got the enthalpy, 3 kilograms, and we've completed the calculation by obtaining 9,693 kilojoules. Let's look now at part D. Here we are required to calculate the internal energy, 2.5 kilogram of steam, 2 bar absolute, 250 degrees. So first of all, remember, we need to make sure that our steam is, in this case, at the condition that we are looking for. So head first for the superheated tables. Okay, if you look at the superheated tables, you will be able to see we have highlighted what we wanted: 2 bar and 250 degrees. We know the saturation temperature again is 120.2. Our steam, we are told, is 250. So our steam is clearly superheated. So we have confirmed that value. And we are asked to calculate the internal energy. The internal energy in this case is 2731. The second row in the cell. So let's complete part D. So what we've done is we've completed part D. Given the conditions, 2 bar and 250 degrees centigrade, we've determined first that indeed the steam is superheated as the saturation temperature is 120.2, but our steam is at 250, clearly must be superheated. We observe from the tables the specific internal energy is 2,731 kilojoules per kilogram multiplied by 2.5 kilogram, which gives us the answer of 6,827.5 kilojoules.